All right. So as soon as everybody takes tests, I'll hand it back and we'll go over it. I got a few people who need to make it up. So, all right. Hmm?
Once again, no.
Do you think you'll finish it now? Then that's probably not a good attempt to take it. So yeah. All right. So unit 7. This should be pretty quick. Again, it's a pretty small unit, so we are probably just going to have a quiz over this. There's not a lot in this unit that we cover. There's just really just the main couple main topics. One is concept of differential equations, and the other is slope fields. Okay. So, equation involving a derivative is called a differential equation. The order of a differential equation is the order of the highest derivative involved in the equation. So let's solve these differential equations analytically by separating the variables to find the general solution. So, really sound worse than they really are. What we're going to do is we are going to get dy and dx on opposite sides of the equation. Okay? So, if I want to do that for number 1, just multiply both sides by dx. So I get dy is equal to 2x minus 5 dx. The goal is to find the original function, find the original equation, basically define y. All right? To do that, we are going to integrate both sides. Now, if nothing is with dy, what's the understood number with it? 1. What's the integral of 1? Well, in terms of y, it'd be 1. So y, all right, technically it should be what? Plus c, but we're not going to put plus c here, and I'll explain why in a moment.
You put plus in the other side.
Yeah. So we integrate over here, and we're going to get x squared minus 5x plus c. Now, the reason why we only put plus c on one side is could we just add the constant onto the other side, and we just have a constant plus a constant gives me a constant? Yeah. So that's why we're just going to add c on one side. All right. This is what's known as the general solution, because my answer could be anything as long as I can have any constant in there, but it would still work. Okay. Now you can find what's called a particular solution, and you can do that if they give you at least one coordinate that works for the equation. You can plug in for x and y and then solve for c. So if they do not give you a coordinate, they don't give you a value that works and ask for the particular solution, this is your answer. That is it. Done. Again, it sounds complex. Does it get a little more complex? Yeah, it does. Of course it does. Yeah.
Where did you?
Are we?
Probably. Well, everything always ends with great.
Let's see.
That's gonna be not. That's not happening. So that's surprising.
Yeah, I don't see it. I don't see any tree.
I like this kind of tree.
All right, so here, again, we do need to get dx and dy on both sides, but again, I want all my y's on one side, all my x's. So I'm going to multiply both sides by dx and multiply both sides by y to cancel out my denominators. So I end up with y dy is equal to negative x dx. So we are still going to integrate. So I get 1/2 y squared is equal to negative 1/2 x squared plus c. If I want to make this a little bit easier, what could I do? By 2? Yeah. Now, is that going to change the constant? No. 2 times the constant is just a constant, so we can leave it as a constant. So I have y squared is equal to negative x squared plus c. What does this look like? A circle. To get it to be a circle, we have x squared plus y squared equals c. If you add x squared over, it wouldn't be. So that's a circle.
In that sort of situation, we have to get it equal to C, or if we had left it.
Left it like that. Actually, technically, if usually you want to get y by itself, so you'd write it as y is equal to plus or minus the square root of negatives x squared over c. X squared plus c. So usually, if you want to get y by itself, y is equal to plus or minus negative x squared plus c. And in those cases, what they would do is they would give you a coordinate that works so you could solve for c. And if the coordinate works, it would only involve what, let's say they give you something like 0, 2 as my coordinate. That works. So this is just extra. If they give us find the particular solution, using 0, 2, that means I plug in 0, I should get what? 2, right? I plug in 0, I should get 2, right? Now, in that case, is my square root positive or negative? If I plug in 0, I get 2 is equal to plus or minus the square root of 0 plus c, right? Be positive because I can't have a negative value there. So my final solution, once I solve for c here, so you would get 2 is equal to square root of c, so 4 is equal to c. So my final answer would be y is equal to the square root of negative x squared plus 4. I would not have the minus there. Now, what if I had negative 2 was my particular solution? Then it would be negative instead of positive. So the key concept there is that anytime you're finding a particular solution, your function must work after you solve for c as well. So this right here is extra. You didn't have to know that yet. All right. So here we're going to multiply again. If I were to simplify this, what would I write next?
2y dy.
2y dy equals 5x dx, and then we are going to integrate, and that would give you y squared is equal to 5 over 2x squared plus c. We can make this easier by multiplying everything by 2. So 2y squared is equal to 5x squared plus c. So we have 2y squared minus 5x squared equals c. What kind of function is that, by the way?
Ellipse.
Ellipse would be adding a hyperbola. Or if you're, from the south, hyperbola. Yeah. No, you don't need to know that. Actually, it's written in my notes. Don't worry, you do not need to know that. Yeah.
I'll let go.
The idea here is you do need to be able to find a particular solution. Now, this is a really good one. Okay?
Say, we multiply by dx.
You multiply by dx, so we have dy is equal to 2y dx, right? But we got to have y with dy. How do I get y over with dy? Yeah. So 1 over y dy is equal to 2 dx.
Oh, just about y.
Yeah. Then we integrate. Now, what's the integral of 1 over anything? Well, 1 over anything with an exponent of 1. Natural log. So natural log of y, absolute value, is equal to 2x plus c. Now, if I want to get y by itself, what would you do to get rid of ln?
Multiply by d.
I don't even multiply by e, but use the equivalent exchange rule. Okay, which basically means make these both exponents with e as the base. Okay, so e to the natural log of y. And once you get rid of, by the way, once you get rid of natural log, you can drop the absolute value, is equal to e to the 2x plus c. Now, this is where it gets a little complex. All right, we are going to get y is equal to e to the 2x, but I'm going to write it like this, times e to the c. Why can we do that? Yeah, when you multiply exponential functions with the same base, you add the exponents. Okay, so when you multiply terms that have the same base, you add the exponents. So you can also do that backwards. If you're adding exponents, you can make them have the same base and multiply. E is a what? Constant. So what's a constant raised to another constant? A constant. We're going to use this letter for the constant, though. Does that look familiar? Yeah, remember PERT and all that other fun stuff right there? Basically, this is what's called an exponential function. Okay, and this is an exponential growth function. So, yeah. So technically you should have the absolute value here, but here's the note, star. Once you have e to the c as a, you can drop the absolute value. And the reason for that is A, your initial value is generally positive, so there's no way we're going to get a negative value in there. And no matter what you plug in for x, e to the 2x can never be negative. All right, so let's look at this. We kind of already talked about this. So find the function y equals f x passing the point 0, 0, given the first derivative. So now, anytime it's multiplication, to bring the y over, I have to bring the 6 minus y with it. So I'm going to have 1 over 6 minus y dy is equal to x dx. What is the integral? Because we are going to integrate. Right, that gives us what? Now you have to be careful here because you can't just say natural log of 6 minus y. Why can't we do that? The chain. We have a chain. So we can either remember to balance that out, and remember if we have a chain, we have to include what? The negative, or we can do u substitution. So u is equal to 6 minus y, du is equal to negative dy. So we have the integral of negative 1 over u du, which gives you negative natural log of u, which becomes negative natural log of 6 minus y. Gives you, again, just 1/2 x squared plus c. Now, we don't really want to stop here. No, what we want to do is get y by itself. So to get y by itself, what do we have to do? Do the e rule. Now we can get rid of the negative. That will make things easier. We can make this the natural log of 6 minus y is equal to negative 1/2 x squared plus c. And again, we do in plus c because it makes no difference what our constant is. Constant can be positive or negative. We won't know until we plug in our initial value, 0, 0. Then we are going to do that e to the natural log of 6 minus y equals e to the negative 1/2 x squared. Again, I'm going to write this as times e to the c, which we then can write as 6 minus y is equal to a e to the negative 1/2, which we can get rid of the absolute value when we bring in a. X squared. Now, we're going to subtract 6 over. So subtract 6. Gives me negative y is equal to a e to the negative 1/2 x squared minus 6. And then we are going to change all the signs. But again, do I need to change the sign of a? No, because it's still a constant. That constant is going to have its own sign. I'm not going to worry about that until I have the actual value for it. But 6 is going to change to plus 6. It would mess with your final answer, yeah. So basically, never change the sign of your constant for any reason.
You only change the plus 6.
Yep. Now, we do have an initial value. Okay, so using 0, 0, 0 is equal to a e to the negative 1/2 times 0 squared plus 6. So 0 is equal to anything to the 0 power is what? 1. So a plus 6 is equal to 0, which means a has to be what? Negative 6. So my final answer is y equals negative 6 e to the negative 1/2 x squared plus 6. There's your final function.
Now, like when we are able to change the sign of a, or will able.
Since I have an actual value for a, if I multiply or divide by negative, I can change that sign. But I couldn't do that until later on. Here's the thing. If you left this negative a, you would have got a is equal to 6, right? Which you would have left still as negative 6 to e. It would still end up being negative 6, no matter what. Okay, because if you left it as negative, you got a as 6, then you plug it in, you still get negative 6 e to the 1/2, no matter what. It's just not much of a point in doing that. It's just, basically, it just makes it easier, I think. Just never change sign of your constant, because when you solve for it, the value will be the accurate value. As long as, again, you solve accurately. All right. Which time we got left? We got 20 minutes. Do we really have 20 minutes? Okay. So here it is. Two. Yeah, we just have 2 questions left, so we can do each question in 10 minutes. It's fine. All right. So the population of a little town called Scorpion Gulch is now 1,000 people. The rate of growth of the population is directly proportional to the population. Write a differential equation that expresses this fact. So, A, rate of growth. The rate of growth is directly proportional to the population. Now, that means that the rate of the population over the rate of time, all right, is directly proportional to the population, which means I am going to have a constant times the population.
Any reason using K or is it just?
K is just a simple, common one we use.
Good. Can do A.
No, we're gonna get A. So yeah, we're gonna get A. But do you remember when we solved this? Oh wait, actually, it tells you what the rate is and what K is. K is that. Yeah, K is the 5%.
What's for big?
Right.
We heard me yesterday.
Solve the differential equation to find the equation that expresses the population as a function of time, given the population presently growing at a constant rate of 5%. So K is the constant rate of growth. When growth or decay. In this case, it's growth. So here for part B, we're given dP over dP. That's not a P. Over dt is equal to 0.05 P. And we are tasked to find the equation for the growth rate according in terms of T. So basically do the same thing we've been doing. So this time we don't have X and Y, we have P and T, which is again the same thing. We need to get P on one side, T on the other. Since P is up top, we need to bring P over here. DT is going to go over here. So we can leave this alone. Just bring the P over. So 1 over P dP is equal to 0.05 dt. We're going to integrate, and we get natural log of P is equal to 0.05 T plus C.
I hate T as a variable.
Why? Because it looks like plus side?
Plus side.
That's why you always curve the bottom. Curve the bottom of your T's and it never looks like a plus side.
Or pencil it.
Yeah, T don't mess up your phone.
Now, absolute value of P is equal to what? E to the 0.05 T plus C. P is equal to what?
Wait, you just put C up.
A e to the 5 T 0.5.
Now, this is our general function. This is our general solution.
So wait, but it's C.
Where is e to the C?
Then we have every time we can write this as e to the 0.05 T times e to the C. Yeah.
Not good.
So this was not our general solution, but do we have a particular value? Do we have an initial value? Yeah, when is it 1,000? Right now, when T is equal to what? 0. So, given T equals 0, P equals 1,000, we could say 1,000 is equal to A e to the 0.05 times 0. Which means what? 1,000 is equal to A. So my particular solution is P is equal to 1,000 e to the 0.05 T. All right, we got 14 minutes. We can do this next page. Right, this is very similar to what we just did. All right. We are going to set it up using that. So, oh, you're in a date. You're in a date and cruising up towards Lover's Lane. Okay. Just before you arrive, you run over a nail and the air leaks out of your tire. The rate of change in pressure inside the tire is directly proportional to the pressure. So again, that means dP over dt is equal to kP. Anytime they say that, it's directly proportional to whatever I'm dealing with. The rate of change of it is directly proportional to the amount of it. That's what we're using. Okay. Now we are given the constant rate. Okay. What constant rate are we given? Hmm?
D.28.
Yeah, 0.28 is the constant rate. This is what? The initial value, the pressure. So I do know I have 0.35, okay, and that K is equal to 0.28. So how would I set this up? Now it's decreasing, which means my K is what? Negative. So setting that up for part A, what is my dP over dt? Negative 0.28 P. All right. Wait a second. No. No. They didn't give us the constant. They gave us the pressure. Is right. They didn't give us the constant rate though. Sorry. My bad. They gave us the change in pressure. dP over dt is negative 0.28. So they want us to find actually K with this. So using that Kp, we can find negative 0.28 is equal to 35K, which means K is equal to what? Negative 0.28 over 35, which is 7 4/5, negative 0.008. B, solve the differential equation. dP over dt is equal to negative 0.008p. Here's the thing. We've solved this a few times. What is this going to end up being?
The
I mean, yeah, if you want to show all the work, again, you should show all the steps. We are going to say 1 over p dp is equal to negative 0.008 dt. So we're going to get, when we integrate, natural log of p is equal to negative 0.008 t plus c. And again, we're going to say absolute value p is equal to e to the negative 0.008 t plus c, which is e to the negative 0.008 t times e to the c, which gives me p is equal to a e to the negative 0.008 t. So at this point on these questions, you should be able to get from dp over dt all the way down to what p is. Because it's kind of the same thing every time, as long as I have 1 over p, right? Which anytime we have exponential growth or decrease, what is it? Growth or decay. That's what it is. That's your exponential growth decay function. It's growth if your rate is positive, it's decay if your rate's negative. All right, so that's part B. Just find the general solution. Part C is to graph this. Now, what does an exponential decay function look like? What value did it start at? 35, and what's it going to? It will eventually go to 0. Now, that's what an exponential decay function looks like. Growth function would go the other way, go upwards. All right, so that's part C. Well, part D. Will the tire pressure be at 10 minutes? So, oh wait, we never finished part A or B, did we? What was the initial value? 35. So P is equal to 35 e to the negative 0.008t. Now, the only reason I can automatically change A with 35 is because they gave me 0, 35, and I don't have any other weird constants being added or subtracted to the function like I did with this question up here. So here we had that 6. So they gave me 0, 0. It doesn't mean A is 0. Because I had that 6, I had a different value for A. Here, anytime I don't have a constant being added to my exponential function, your initial value for 0 is your A. If you remember, usually they write it as A sub 0 as your initial value. So now I can say, how much pressure will I have after 10 minutes? What is 35 e to the negative 0.008 times 10? I'll have 32.31 psi. And part E. The car is safe to drive as long as tire pressure is 12 psi or greater. For how long after the puncture of the tire do you have a lover's lane before a tire goes flat?
So would you say 12 equal to that and solve for?
Yeah. So 12 is equal to 35 e to the negative 0.008 t. So how do you solve for that? Yep. Divide by 35 first. So 12 over 35, which doesn't reduce, equals e to the negative 0.008 t. All right, then we do what? Natural log. 12 over 35 is equal to negative 0.008 t. So t is equal to natural log of 12 over 35 divided by negative 0.008. So natural log divided by 35 divided by negative 0.008. So how many minutes do you have?
8-1.
133.81 minutes. So a little bit over 2 hours. I don't think it is either. I want. Well, the thing about tire pressure though is as long as you're driving, the pressure will generally remain constant even with a punctured tire, unless it is like really big. But if you have something slight, the nail's in the tire still, then you have something blocking the air from going out, and as you're driving, the pressure will be fine. But once you stop, it'll start to deflate. Do you know how I know that?
No.
Because it happened to me, and my car actually has a button you can check the tire pressure as you drive. So it's really nice. But yeah, every time I stopped, I saw it go down. I was like, that's not good. Well, it would have been fine if I wasn't driving from Florida to St. Louis at the time.
You get the flat tire?
With the family. Yeah, we got it in Mississippi. No, was it Mississippi? We didn't go through Mississippi that time. We went through Alabama.
My uncle got one. He like the run like terrible.
Oh, that's Arkansas sucks. We do our best not to go through Arkansas. Arkansas. So I don't know which one I dislike more driving through, Arkansas or Illinois. I don't like Illinois.
Illinois, their roads are good. Like,
When they're not being worked on all the time.
Yeah,
I feel like
that's true.
I was
Yeah, it's true.
Sydney is down on St. Louis is 4, right?
like north 270. One of the changes from north.
So
Yeah, St. Louis is good. Though there is a worse place than St. Louis. Not Memphis. Is it Memphis?
Might be Memphis.
What other cities in Tennessee?
Uh,
No.
Not
Tallahassee's in Florida.
Yeah.
Maybe it's just Memphis. No. There's one city that's worse in Tennessee.
Yeah, it's probably.
I don't think it is Memphis. Nashville's the worst. Nashville's driving through. You do too. It's fine. Yeah. If you ever try to drive through Nashville, it's terrible. Yeah, you go around it. Go around it. Even then, because their lanes go from like 6 to 2 for some reason. It just
Like instantly, just
it's like real soon. And they're working on it. The problem is they landlocked a lot of their roads. There's not much they could do.
it's funny. My time in Indianapolis, one of the
Okay.
highways they had, it was a 2-lane highway. They were working on one side of the entire highway for like 15, 20 miles.
Yeah, I don't understand that.
And so then they had, obviously that side shut down, so they just shifted it over. So like one lane was driving on the shoulder, pretty much like almost touching the grass. And the other lane was encased in barriers.
Yeah, so of course he has to do
At least you had 2 lanes.
So you had to be like 10 feet.
White knuckling it, yeah. Yeah.
Like focus then stuff, or else you're either going off the road or hitting a concrete wall. That was not fun because I was driving at the time. And I was 16. I had just got my license.
Yes. When I had my permit, my family decided to take a trip to DC. And we had this Chevy Astra van. And we had, the fun thing was, it's something really fun. We took out all the seats but the front 2 and put just bean bags on. Now, was it safe? No. There's no seatbelts.
Yeah.
But it was the best trip we've ever had. Downside is since we have just bean bags in the back, we're all just, so me and my brother and sister, we just basically slept on those things. We had to put all our luggage on this little cargo carrier up top, which made the van top heavy. So my brother almost flipped us because he was about to miss his exit, and he went like that.
Then across the bank.
Oh, what side? And then I got hit while I was driving with a downpour to where I could see the lights of the car in front of me, and that's it.
Oh wow.
So my mom pull over, I'm like, where? I can't see.
I'll say driving's fun.
Yeah.
And sometimes I think I'm getting by.
All right, y'all have fun.
I think